today we're going to be solving equations, and this is going to be in Module 1. We're going to start very basic with the equations, and every day we're going to add more steps, and they're going to get a little bit more advanced. So, anytime we're solving equations, our main goal is to isolate the variable. We want to get that variable in the equation all by itself, and to do that, we're going to be using inverse operations. Inverse operations are operations that undo each other. And in math, we have 4 math operations. Those are addition and subtraction. So those are pretty straightforward. You got the plus sign, subtraction. Addition and subtraction, they undo each other. So these are known as inverse operations. The other 2 operations, multiplication and division. Okay, so multiplication looks a little bit different moving forward, because usually before we would have the x to represent multiplication, but it's going to get a little weird if we have 2 times x, because you know how x is a very commonly used variable. Well, if we use the x for that multiplication symbol, it's going to get confusing. So moving forward, we don't use the x for multiplication. Instead, you'll know that you're multiplying, as mentioned in the video with the coefficients. Remember, if we have, so to show 2 times x, I could go 2 and then the x right next to it, because multiplication, it's implied when a coefficient and a variable are next to each other that it is multiplication. Another way you can write this is 2 with the dot x. Okay, so that dot can represent multiplication. Also, another way to represent multiplication are parentheses. I could do 2 parentheses x. Anytime you have parentheses, it means multiplication. So this would be 2 times x. Another way you could do this is putting them both in parentheses. Okay, so all 4 of these show the same thing, 2 times x. So those are the 4 ways you can do it. The only time you wouldn't want to just leave the 2 things right next to each other are with just numbers, because if I wanted to do 2 times 5, I can't leave the 2 numbers right next to each other, or else that looks like a 25. So in that case, you would use one of these other ways. Okay, so you can only leave them if it's leave it like this if you're dealing with variable and a number, not just numbers by themselves. Okay, so in this case, I would write like 2 times 5. All right, division. So division, we have that symbol. So moving forward, we're not really going to be using this. Instead, we are going to be, here's my little note, we're going to be using a fraction bar instead of that division symbol. So if I wanted to do x divided by 2, I would show that with a fraction bar. So this is how we're going to be seeing division from now on. All right, and then multiplication and division. So these 2 math operations, they undo each other. So these are known as inverse operations. All right, so now let's jump into some examples. So example 1, x minus 7 equals 5. So with equations, what I like to do is I like to draw a line separating my 2 sides. And first, since our goal is to get the variable by itself, first I go in and I find my variable. Well, here is my variable x. So I like to put a box around my variable, because it lets me know what side I'm going to be working on. So here I'm trying to get x by itself, but right now x isn't by itself because there's a 7 that's being subtracted from it. So I need to undo that subtraction. So the opposite of subtraction is addition. So I'm going to add 7, but I need to make sure that my equation stays balanced. So in order to do that, you have to remember the rule, whatever you do to one side, you have to do to the other side. And then you can simplify. So negative 7 plus 7 zeroes out. I can drop down my x equals 5 plus 7, which is 12. And that's my final answer. Okay, example 2. X, and we have that fraction bar, so that means division. So x divided by negative 3 equals negative 2. So I'm going to draw my line. And find your variable because that lets you know which side you're going to be starting on. So here's my variable. Right now, x is not by itself because it's being divided by a negative 3. Well, I need to undo that division, so I'm going to, instead of divide by a negative 3, multiply. I'm just going to use the dot. Multiply by a negative 3. But I need to make sure to keep my equation balanced, so whatever I do to this side, I have to do to the other side. And then the reason why I can do this is because a negative 3 divided by a negative 3, any number divided by itself, equals 1. So that just goes to 1, so I'm left with 1x. But remember that coefficient of 1 is invisible in math, so I can just write x, which is the same thing as 1x, is equal to negative 2 times negative 3. A negative times a negative makes a positive, and 2 times 3 is 6. All right. Next example. All right, so we have the example 3/5 x equals 9. So this one, there's two ways you can approach it. You can either, there's one way I'll show you, and we can do it in 2 steps, or there's a 1-step way. So first, I'm going to show you the way to do it in 2 steps. Okay, so 3/5 x equals 9. Well, what you can do first is multiply by that denominator. Get rid of the denominator. So kind of like what we did in example 2. We can clear that denominator by multiplying by whatever's in that denominator. So here, the denominator is 5, so I can multiply by 5. But I got to make sure to do it on both sides. So I got to take this 9 and multiply by 5. This allows the 5s to kind of cancel out because 5 divided by 5 is 1. Okay, so then I'm left with 3x. So I got to drop that down. Also, I forgot to draw my line. Okay, so you see how those canceled out, and then always make sure you look at your numerator to see what's left. Okay, so I dropped down the 3x is equal to 9 times 5, which is 45. And now it's back to those 1-step problems that I did in the previous examples. Here's my variable. I need to get that by itself, but right now x is being multiplied by 3. So I need to undo that by doing the opposite, which is dividing by 3. And you have to do it to both sides. 3 divided by 3 goes to 1, so I'm left with 1x is equal to 45 divided by 3, which is 15. Okay, so that's the first way you can do it. It took 2 steps by first clearing the denominator, and then I had to divide by the coefficient. So let's take a look at the other way. This way is a little bit faster because it takes 1 step, but not everybody's comfortable with this way, but I'll show it to you. Okay, so here's the same problem. So I can clear this fraction in 1 step, and that is by multiplying by the reciprocal. And the reciprocal just means a flipped version of your fraction. So I need to multiply by the reciprocal. So I take this fraction and I flip it. So the denominator of 5 now becomes the numerator. The 3 now becomes the denominator. So I just took this fraction and flipped it. And I have to do it on the other side as well. Gotta keep the equations balanced. So it's just like the other problem. See how the 5's are going to cancel out because 5 divided by 5 is 1. 3 divided by 3 is also 1. So that's why I'm just left with 1x on the left. And now I've got to simplify this. 9 times 5/3. Well, to make any whole number a fraction, you just put it over 1. And then with fractions, when you multiply, you just multiply straight across. So 9 times 5 is 45. 1 times 3 is 3. Okay, but I can simplify this fraction. So 45 divided by 3 is 15. So I got the same answer, but this one I was able to clear that fraction in 1 step. So you can choose whichever way you feel more comfortable doing. Most people like this one, but if you're comfortable with reciprocals, go for it.